Hello everyone, good afternoon. Sharmina here. I would like to welcome you all to our today's tutorial on structural forms and analysis. Our today's topics is truss analysis. We will do some problem solution and we'll know to some concept of truss analysis. First of all, we need to know the definition of a truss. A truss is a structure that composed of a slender member joined together at their end points. The members commonly used in construction consists of wooden studs, metal bars, angles of channels, and the joints connections are usually formed by bolting or welding the ends of the members to a common plate called cast plate, or by simply passing through a large bolt or pin through each of the members. Here is two picture of a truss. This is a bridge truss in Pennsylvania, and this is a timber truss on a commercial building's roof. To do the truss analysis, we need to know the methods to find out the forces of the truss members. There are two mathematical methods. One is method of joints, another is a method of sections. Method of joints: at each point the forces are considered and two equations of equilibrium are established for forces components in two mutually perpendicular directions. These equations are then solved simultaneously for up to two unknown forces. So I think you remember the equation of equilibrium, that is function of x equal to 0 and function of y equal to 0. So in case of method of joints, for each joints we have to satisfy these two equations and calculate the force. For method of sections, this consider the equilibrium equation for a whole portion of a truss rather than just one joint at a time. Now we are going to solve some problems. First we will solve a problems with method of joints. Please let me know if you can't follow me, or let me know in which point you are in trouble, so that I can reply to you appropriately. Okay. In this problem is from activity 5.1 of workbook 1, assignment item 2. You have to submit assignment 1 and 2 at 13th of April. In this activity, use the method of joints to compute the member forces in the truss shown in figure 3. So in this figure you have to calculate the forces of each member of this truss. So let's see how we can solve this. First consider each joint. First we can start from the joint F. This point, just draw a free body diagram for joint F. Okay. This is a free body diagram of joint F. We have to consider the force for this member FA, and for this horizontal member FZ, and the external force 5.7 kilonewton. So do you have any question regarding this free body diagram? Okay, then I'm going for the next one. From this figure, we can say function of x equal to 0, or first equilibrium equation. In that case, we have to consider the x axis forces Fz equal to 0, and function of y, our second equilibrium equation, Fa equal to 5.75 kilonewton. We have to consider this one and as well as this one also. So we already get the two forces of this member and this member. Next, we will consider joint A. We have to draw the free body diagram for joint A. This figure is for F. This figure is for joint A. Okay. And this is the free body diagram of joint A. So from this diagram, we can say the equilibrium equation like this. Just look at this. If function of y equal to 0 in this figure, FAB cos 45, this is the component of vertical component of FAB. FAG cos 45 plus FAF, this is the vertical forces FAF equal to 0. So we already know the value of FAF from here, 5.75, and put the value in this equation. You will got the value force of FAZ, which will be 8.13 kilonewton. So now we know the forces of this member FAZ. Next, we have to consider our second equilibrium equation, function of x equal to 0. In that case, FAZ cos 45 this should be a z, because this is the G point. Okay. In this case, FAZ cos 45 minus FAB is 1, and FAB equal to 5.75, because we already know the value of FAZ and we can find the value of FAB. So do you have any question up to this equation? And it would be highly appreciated if you have questions, so that I can go for the next one. Okay, so I'm going to consider our next joint, joint G. So first draw the free body diagram for joint G. That actually for this joint, free body diagram will be like this. From this point there are four forces, FGH, this one, and FGB, this member, and FAG, this member, and FGF. Write the equilibrium equation with this figure, considering the vertical forces Fy equal to 0, FGB plus 8.13 cos 45. 8.13, we already know this value from our earlier equation, the value of FGA. So we just put this value here, and this value 1.5, that is acting here, this force 1.5. So for the vertical portion you have to consider three forces, and after calculating this you will get FGB 4.25. so we already know that this value FGB, just the force of this member. After that we will consider the equilibrium equation for function of x equal to 0. In this case we will consider FGH, these forces, minus 8.13, again the value of FGA, this is the x component of these forces, and then FGF, these forces. Okay. Just put the value of FG. We already know the FGF value equal to 0 from our first equation. Just go to our, from this equation, FGF equal to 0. Just put this value and calculate this equation for forces of GH member, and the member forces is 5.75. Okay. Now consider the next we will consider joint B, and we have to draw the free body diagram for joint B. This joint, the free body diagram will be like this one. This is for 3 kilonewton, and this is force BC. This force is for force AB. Okay. This is for BG, and this is for BH. In this figure we can write the equilibrium equation for function of y equal to 0, if BH equal to cos 45. For the vertical force we have to consider this 3 kilonewton, FBG and FBH. So FBH cos 45 minus 4.25, FBG equal to 4.25. So we got this value from our earlier equations, and plus 3 kilonewton, that is directly applied to this point. After putting this value and calculating, we will got the value